This video is looking at speed. Speed is a rate at which you travel. It's a ratio between the distance travelled and the time taken. We usually simplify that ratio down to how far you travel in 1 unit of time. For example, 60 kilometers per hour means you travel 60 kilometers in 1 hour. 30 miles per hour means you travel 30 miles in 1 hour. 25 centimeters per second means you travel 25 centimeters in 1 second, and so on. So when we have 300 kilometers in 5 hours, so the ratio there is 300 to 5, we would simplify that ratio down so it becomes, in this case, 60 to 1. If I divide both of these by 5, I reduce the distance to 60 kilometers and the time to 1 hour. So I've got how far we travel in 1 hour. That's the way we like to quote speeds, how far you travel in 1 unit of time. So its distance gets divided by the 5 of the 5 hours. The distance gets divided by this 5 of the time. And in general, you can say then speed is distance divided by time. It's simplifying the ratio down to 1 unit of time. So S equals D divided by T, or as we'll write it, S equals D over T. So we want the average speed, the speed at which you travel on a journey, say. Formula S equals D over T. We're dividing the distance by the time. So we want to divide 360 kilometers by 2 hours 15 minutes to find out how far you go in 1 hour. 15 minutes is quarter of an hour. As a decimal, that's 0.25. So this is 2.25 hours. So it's dividing 360 by 2.25. And if you have a calculator and you're going to use it, then use the fraction button and enter 2 and 15 sixtieths. 2, fraction button, 15 at the top, 60 at the bottom. That way you can enter any number of minutes quite easily and just simply have 360 divided by 2 and 15 sixtieths. It will come out exactly 160. So you're travelling 160 kilometers in 1 hour. So S equals D over T. Speed is distance divided by time. Dividing the distance by the time is just finding out how far you go in 1 hour. So this all has to be in hours. So we have to get rid of the minutes. 15 divided by 60 on the calculator, 15 sixtieths. So here, travel 240 miles in 4 hours 10 minutes. You want to have 4 hours 10 minutes into hours only. So you want to divide the 10 by 60 to get the fraction of an hour. It will be the recurring decimal 0.1 and then 6 recurring. Or better still, on the calculator, enter 4 and 10 sixtieths. So average speed, S equals D over T. Distance 240 divided by the time in hours. That's it as a decimal with these recurring 6's. Or better, use 4 and 10 sixtieths on the calculator. It'll come out exactly 57.6. That's how many miles you do in 1 hour, so it's mph, miles per hour. So, formula to memorise is S equals D over T. Now suppose you want to calculate the time of a journey, knowing its distance and speed. The speed here is 60 kilometers per hour. That means in 1 hour you travel 60 kilometers. So the time it takes to go 300 kilometers is how many 60s are in 300, because that's how many hours it'll take. So divide 300 by 60, because that figures out how many hours there are involved in the journey. It's the distance divided by the speed. So the formula, time is distance divided by speed. T equals D divided by S, or as we'll write it, T equals D over S. So here, you're travelling 360 kilometres at 160 kilometres per hour. The time taken is distance divided by speed, T equals D over S. 360 divided by 160. Out comes an answer in hours, because it's 160 kilometres per hour. By seeing how many 160s were in 360, you're figuring out how many hours there are. the decimal 0.25 hours. If you take 0.25 and multiply by 60, it will turn that fraction into minutes. And your hours in minutes are now 2 hours 15 minutes. So that 15 minutes, quarter of an hour, that's the fraction 0.25. Now, here, 100 miles at 24 miles per hour, find the time taken, t equals d over s. First thing is to write the formula, put in the figures, 100 divided by 24. Out comes the answer. It's got a recurring decimal here, 0.16666, and so on is the decimal part. If you times that by 60, you turn the fraction of an hour into minutes. So to keep this unrounded, you would take your answer, subtract 4 to leave you the decimals, 0.166 and so on, and multiply by 60 to turn the hours into minutes, and it's 4 hours 10 minutes. If you round that off at all, you'll knock out this answer from being exactly 10. So that's time is distance divided by speed. So we've had s equals d over t. Speed is distance divided by time. The other formula is t equals d over s. Time is distance divided by speed. And the third formula is for distance. So here, speed 60 kilometres in 1 hour. You travel for 5 hours. Well, you're going to go 5 lots of 60. So for 5 hours, it's 5 times what you do in 1 hour. So it's 5 times 60. In other words, speed multiplies time. So to get the distance, you multiply speed and time. D equals S times T. Always I'll write it, D equals ST. So to get the distance, you multiply speed and time. So here's the speed, 20 kilometers an hour. The time, 2 hours 15 minutes. Find the distance, formula, D equals ST. Multiply speed and time. This is kilometers per hour. So you need this time all in hours. As before, 15 minutes, quarter of an hour, decimal 0.25. Or better still, 2 and 15/60ths on the calculator. It'll come out exactly 45. And because it's been kilometres per hour, you're finding out how many kilometres you do in the time. So the unit of distance here is kilometres from the speed units. 36 miles per hour for this time. D equals ST. 36 is the speed. It's per hour, so you need this time in hours. 35/60ths here. If you divided 35 by 60, you would get this recurring decimal. But better still, use 4 and 35/60ths on the calculator. So 36 times 4 and 35/60ths. And it will come out exactly 165 miles, because that was miles per hour, and you'll find out how many miles you do in that time. So D equals ST. So that's the 3 formulae. Here they are summarised. This triangle is often used to memorise formulae in, say, physics. So this is S is D over T. This is, over on the right, T is D over S. And in the middle here, the D in the top, S and T are together. D is ST together. That means speed multiplying time. If your time units involve minutes, divide by 60 to make it a fraction of an hour. If your answer here on the right for your time comes out as a fraction of an hour, times that fraction by 60 to make it into minutes. That was seen in each of the examples. So this triangle, if you memorise it, memorises the 3 formulae that you need to use. So the 3 formulae are for working out the speed, or the distance, or the time. First thing you write in any question is the formula, and then you put in the figures. So here's the speed at which a human hair grows, 0.25 millimetres per day. So John's going to allow his hair to grow to 3 centimetres, that's the distance. How many days is it between visits to the barber? So millimetres per day, and this is in centimetres. You want the distance to match the speed units. 30 millimetres for 3 centimetres. So to find the time, formula T equals D over S from this triangle. Distance is 30 millimetres, and that's the speed, 0.25 millimetres per day. Simply put the figures in. Comes out exactly 120. So it's 120 days, because that's millimetres per day. So this one says speed of sound, 330 metres per second. Thunder's heard 15 seconds after the lightning, so that's the time, 15 seconds. So we've got the speed, we've got the time, how far away that is, what's the distance, how far away is the lightning, so it's what's the distance, d equals st. There's the triangle. Multiply speed and time, that's metres per second, and this is in seconds, so that's all fine, the units match up. And it comes out in metres, because that's in metres per second, so it's 4,950 metres, so it'll be handy to change it to kilometres, 1,000 metres in a kilometre. So it's away a distance 4.95 kilometres. Third case. So this is light from the sun. It takes 500 seconds to travel to the Earth, so it's time 500 seconds. The sun's distance is 150 million kilometres from the Earth. That's the distance. So I've got the time, I've got the distance, and what's the speed? So speed is s equals d over t. Distance is 150 million. That's 150 with 6 zeros after it. So in the calculator, you can enter it as 150 with 6 zeros after it if your display would take it. But in standard form, scientific notation, that's 1.5 times 10 to the power 8. There it is worked out there, 150 million, 150 an extra 6 zeros. So if you put it in standard form, you're shifting the point 8 places to get to 1.5. So in the calculator, that would be entered as 1.5 times 10 to the power x button. Depends on the calculator exactly what the power button there is. 8, so it's times 10 to the power 8. And you simply get this answer off the calculator, which may give you as 300,000, or it may give it in scientific notation, depends how your calculator's set. So it could say here 300,000 kilometres per second. You can set your calculator to go to standard form, or to leave it as 300,000. So that was the 3 formulae being used. So when you read a question, you've got to say what they want me to calculate. So here it's how many days, they're after the time, and write the formula. And after that it follows through, you just got to watch the units. Here we've got to match up centimetres and millimetres. This one, which was how far away was the lightning, we're finding the distance, so you get the right formula as d equals st. And here, you're asked to find the speed, so that's s equals d over t. The units match up automatic because it's kilometres and it's seconds. So it's going to come out as kilometres per second, so you don't have a unit problem here. Now, some of the questions involve clock time, which you should be able to get time differences, because obviously if you're working out speed and you need the time, that could be given in terms of time of day. So you should know 24-hour clock. So if it's 6:25 AM, you should know that's 06:25 or 06:25. If it was 6:25 PM, you add 12 hours onto the 6 hours here, so it's 18:25. Tend not to put a point in here because it's not decimal. Sometimes you'll see it written with a point low down, but prefer just a little space. 12 noon, that's fine, that's 1200 hours. And midnight can be 2400 hours or 0 hours. So that's the 24-hour clock. What's the difference between writing 6.25 hours, which is 6 1/4 hours, 6 hours 15 minutes, and a time of day like 6:25 AM, and not mix them up? So that is not a decimal point when you write 6:25 AM, whereas it is a decimal point when you write 6.25 hours. So here we're adding up time. So if you're adding 3 hours 36 minutes and 2 hours 43 minutes, and you add these together, the just add the minutes, add the hours. When this goes over 60, that's another hour you've got. So this is 19 minutes on top of another 60 minutes. So the extra 60 minutes makes the 5 hours up to 6 hours. So you just add up the minutes, you add up the hours, and if it goes over 60 minutes, that just gives you an extra hour. Our time differences will be quite common. So if you're going from 8:25 AM to 4:40 PM, suggest you put it into 24-hour clock. And it's a bit easier then to get hours and minutes, because you simply say 25 minutes off the 40 minutes and 8 hours off the 16 hours. So 25 minutes to 40 minutes, that's 15-minute difference, and 8 hours off the 16 hours is 8 hours. That's a straightforward one. Here, put it into 24-hour clock, and here it's trying to take 40 off 25, so that won't work. So the best thing here, I would think, is to make the 0840 up to around hour, 0900 hours, that's 20 minutes, and then go from 0900 to 1625. It's quite easy, it's 7 hours 25 minutes. That's quite easy to get. And then just add the two bits together. So here we are trying to take 40 minutes off the 25 minutes. That's not convenient. Just figure out up to a whole hour how many minutes, and then go from that whole hour in 24-hour clock up to the 1625 here. It's quite straightforward. You simply add on 7 hours to make it 16 or 25 minutes. Or if you like, you take the 9 hours off the 16. And it can go over midnight, so here's 10:35 PM to 2:20 AM the next morning. So 24-hour clock, get it up to midnight first. So 35 minutes, you want to make that up to 60. And then that makes you at 2300 hours, and then another hour makes it 2400 hours. So 1 hour 25 minutes takes you up to midnight, and then 2 hours 20 minutes on to 2:20 AM in the morning. So that's quite straightforward, 2 hours 20 minutes, and you add the two bits together. So here's another in the same sort of way. That's 22:20 up to midnight, 1 hour 40 minutes, we'll make that up to midnight, and then 2 hours 35 minutes after that. Now when you add these together, you're over 60 minutes, so it's 4 hours, excuse me, it's going to be 4 hours 15 for that part. There it is, 4 hours 15. And when you're on a journey, we're always working at the average speed. It's the total distance you travel over the total time you take. So you're not finding the speed at any particular instant. So we refer to that as being the average speed. It's not a speed you actually travel at. So, for example, if you travel 23 kilometres in 30 minutes, and then you travel the next 30 kilometres in 45 minutes, and the next 13 kilometres in 15 minutes, and you want your average speed, you don't work out individual speeds. You simply add up the distance and you add up the time. So you're travelling a total of 66 kilometres in a total of 90 minutes. That's an hour and a half, 1.5 hours. And use the total distance you travelled and the total time you took to work out the average speed. And at no stage do you work out that you've just gone 46 kilometres an hour, or here 40 kilometres an hour, and here 52 kilometres an hour. So at the three stages there, you're travelling at 46 kilometres an hour, then 40 kilometres an hour, then 52 kilometres an hour. But that's irrelevant. They don't get involved in any way. You simply want the total distance and the total time. So the kind of problem you'll get with this is a bus that travels 560 kilometres in 5 hours. For the first 300 kilometres, averages this speed of 125 kilometres an hour. For the next 260 kilometres, what's its speed? So with this, you figure out how long the first part of the journey took, 300 kilometres at 125 kilometres an hour. and then you work out the last 260 kilometres. So time equals distance divided by speed. 300 kilometres at 125 kilometres an hour will take you 2.4 hours. You don't need to know how many minutes that is. It's 2.4 hours. It travelled a total of 5 hours, so you see the time that's left. Of the 5 hours, there's 2.6 hours left. That 2.6 hours is for the last 260 kilometres. So average speed for the last 260 kilometres was distance 260 kilometres divided by time 2.6 hours. So it's exactly 100 kilometres an hour. So time for the first stage of the journey, and then from the time that's left, you can work out the speed for the second and last stage of the journey. There is a worksheet available if you click the link in the description. It covers speed, distance, time calculations using the 3 formulae, given one of the time units or the distance units or the speed units, whatever, and then it's followed by questions which are based on clock time, 24-hour clock. So questions there involving time differences using 24-hour clock, followed by questions of the type, like that last example, where the journey's in more than one stage and you're working out, using the formula, you're working out time and speed. So time of a leg of a journey and the speed for the second leg of the journey. So these will have answers with them. So click the link in the description and you can get the worksheet. It goes right up to these 25 questions. There's also a set of notes there that cover speed. So there'll be a worksheet on time differences with answers. So that's to practice time differences. There's a worksheet on the 3 formulae I just mentioned, going right up to question 25 with answers. And there's a set of notes covering their time differences, the 3 formulae, and the next video will be in graphs. Looking at speed and time on distance time graphs. Hope you found this video useful.